As Mauro said, my name is Peter Sommerlad. I teach now for 11 years in HSR Rapperswil. The good thing is we teach practitioners and I'm a practitioner. I don't have a big background in HPC. I'm a compiler guy and IDE guy, so you can ask me a lot of stuff about C++, but don't expect me to be able to answer any HPC specific questions, how something runs on this kind of computer using. I hope Mauro will help me with that.
I will try to do my best.
Yeah. But nevertheless, ask if you have a question in that context. We are both here to help you. The next thing is, if you want to learn something specific, tell me. There's much more I could tell you about C++ that fits in 1.5 days that I'm here. And I'm sure I will miss something you're interested in. And if I teach you as a group something where the majority is, okay, that's too old, too basic, tell me so. I might start with some basic things to get us on the ground, but I will not teach you, let's say, elementary programming. So I expect you to know what an if statement is, a while loop or a for loop or whatever. Yeah, and you wanted to have everybody introduce themselves. So maybe I start first with the slide that I have. It gives a bit of background where I come from. I studied informatics in Frankfurt, worked at Siemens Corporate Research, and then came to Switzerland 18 years ago, or a little bit more than 18 years ago now, to work in a small company that I co-owned there. I headed the software engineering department of that small company. And 2004, I joined HSR to work on, I would say, refactoring tools, especially for C++. If you use Eclipse CDT or now our brand version Cdevelop, the refactoring infrastructure there was created by my team. My claim is to make software simpler and smaller. So the goal is to make software 10% its source code size with a better performance and better design. And I care about C++. That's, I would say, one of the languages that I know C longer, but C++ I know and use since 1989, which is quite some time. And I suffered from C++ of the 90s, and going to the HSR helped me to learn C++ in a better way. The best thing is to learn something is teach it. That's why I'm here, to learn more about C++. That's it. And
okay, let's try to understand also you guys. So I will pass the microphone around the room, and if you can generally introduce yourself and why you are interested in this C++ course and C++ in general, that would help us. So thank you very much.
And if you have a specific C++ question, tell us. I will try to take a note, but I won't have a pen yet.
Yes, I will get pens. We got pens there.
So, good morning. My name is Sven Kraus. I'm working at the University of Applied Sciences in Zurich. I am a group member of a safety critical systems group. My background is computer engineering, and I worked until 2014 in the industry, managed a lot of software engineering projects, and I'm quite interested in now going parallel.
Good morning, my name is Patrick Eschle. I'm also from the Zurich University of Applied Science, as Sven. I'm teaching physics there, and my link to C++ is a software called Xian4, which does a propagation of ionizing radiation, for example, X-rays in metric. And I try to learn more about C++ today.
Good morning, my name is Jura and I'm a PhD student here at the University of Lugano, and I'm working on solver for energy systems that use stochastic optimization, and I'm working on pure component solver that uses TPI.
Good morning, I'm Radim. I'm also a PhD student here in Lugano, and I work in HPC.
Hello everybody, I'm Christopher from CSCS since the middle of May, and I'm working in the user support group and part also on a C++ project. I I'm a physicist and I worked in the last years also as software developer, C++, for HPC and for remote sensing in particular.
Hi, my name is Filippo. I'm from ETH Zurich. I'm from the geophysics department, and I'm mainly here to learn how to properly use some C++ features towards the edge performance computing, of course. I learned C++ in a very naive way, starting just reverse engineering an existing code that was handed in as soon as I started working, so hopefully this will be more helpful.
Hi, I'm Greg. I started my PhD at ETH Zurich and I work in computer science department in HPC lab, and I want to learn here how to, in practice, develop what I want to know from theory.
Hi, my name is Carissa. I'm a PhD student at ETH Zurich. I study physics, and my link to C++ is to develop some software for PET imaging, and that's it. I'm here.
Hello, I'm Jean. I'm the responsible for scientific visualization here at CSCS. I actually spend half of my time with Python and the other half with C++.
Good morning, my name is Alfio. I'm a postdoc at ETH in material nanosim group. So we do simulation nanomaterials, mainly write Fortran, even if I feel like a C++ programmer because of my background. I was working in CERN and previous I also collaborated in GEM actually. So, and I like the point that 10% reduce the size of 10%, so I'm more interested in patterns, not so much in performance, even be very interested to understand how to improve the performance of the code, but actually how to write good code and testing, I like also the pragmatic programming at the end, so I would be very interested.
Hello, I'm Pierre. I'm a PhD student from the University of Geneva, where I develop parallel models using C++ and MPI, and I'm basically here to try to learn how to write better C++ code.
Hello, my name is Pascal. I work for ETH and Meteoswiss, and I'm there mainly as a maintainer for our C++ dynamical core. I'm here to learn about how to make our code more efficient and more maintainable.
Good morning, everyone. My name is Stefano, and I'm a PhD at USI University here in Lugano. And my background is mainly chemistry, but in my PhD I will work with programs which are written in C++, so I'm here to learn as much as possible for C++.
Hello, I'm Omar. I'm a postdoc here at USI, and I'm developing methods for animal dynamics. Just want to learn more advanced feature of C++.
Hello, my name is Janis. I'm also a PhD student at ETH Zurich, working on tomographic image reconstruction, and my goal is to learn more about especially the new features in C++, C++11, C++14, and help to learn some more efficient features.
Hello, I'm Mauro Carozzo. I work in the Institute for Calculus Application of the National Research Council in Italy, and I'm interested in understand how to apply C++ to improve the performance of our parallel applications.
Hi everyone, I'm Will Sawyer. I'm a computational scientist here at CSCS and mainly active in climate modeling and numerical weather prediction. I'm a very sad Fortran programmer and I'm trying to branch out into the C++ world, and this course will be very, very useful for me.
Hi, my name is Mahmoud. I'm a PhD student at ETH. I'm generally interested to see what's new in C++ since 2-3 years ago. That's all.
Hi, I'm Fabio. I am a PhD student at the Institute of Computational Science here in Lugano, USI. And I'm working on HPC for selective inversion of matrices, so high scalable computing for numerical problems. And this is a very important course since we are using a lot of C++ code and the CSS, only CSS machines, so I hope it will be an improvement.
Hi, I'm Marcos. I work here at CSS, mostly in GPU computing for climate models. I'm here to catch up with a few of the more recent things in C++.
Hi, I'm Paolo, and I'm working at ETH as postdoc at ETH Stack, and also here in Lugano, and developing C++ stencil library for HPC.
Hello, I'm Hans-Christian Stadler. I work at PSI, Scientific Computing Group, and specifically I develop a code for typographic reconstructions, and I'm interested in the new features of C++ 11 and especially in threading. And I also have one wish to you, this is the memory, connected with the memory model. There is in the standard, when I read it, there are partial orderings, like happens before, inter-thread happens before, sequenced before, and stuff like that. I have some interplay, and so that I have not understand just by reading quickly the standard.
Okay, the memory model. First, it is known that it's still buggy. At least there's one specific part that is not implementable on current hardware, and people on the parallel group are working on that in the ISO standardization committee. But I would like to teach you C++ so you don't have to care about the memory model, so that your code just works. If you go that deeply down, that's beyond my abilities to understand and explain as well. And there are a few people I can point to you in Cambridge that actually proved parts of the C++ memory model found in, let's say, superfluous specifications that we got rid of in C++ 14. And if you're really deeply interested in all the details and theory behind that, I can point you to them. One name that comes just top of my head is Mark Betty, and he will be able to explain to you everything about the C++ memory model from a theory point of view. And that's beyond my abilities, I have to confess.
Hi, I'm Lucas. I'm a computer scientist here at CSCS, and I'm here to learn the new features of C++ 11 and 14.
Good. Thank you very much. Okay, I first start with slides from a talk that I gave that you might have seen already, Simple C++. And that's my goal. There's a bunch of questions. You mostly answered the first one already. I start with the second one. Who writes regularly things using a plain pointer and then instantiating a class object on the heap? Who is not doing that deliberately? Okay? I hope there are more hands up in the end of the course. Who knows how to use vectors of string? Who has never used a vector? Who's not using vector? Okay. Who could say from himself or herself to prefer algorithms that are canned loops, more or less, over handwritten loops? A few. Okay. Who has used the Boost libraries? Some of them. Who knows that Boost exists? Who has never heard of Boost libraries? Okay. Now you heard. Now you heard. There's a library collection called Boost. It's kind of a staging area for things that might become standardized in C++. Who has read Janus Trustup's C++ programming language? I would like to ask for the 4th edition, which is the C++ 11th one. 3rd edition? 2nd edition? 1st edition? Okay. Who has read Scott Meyer's Effective C++ third edition. Something. The effective modern C++, the new one. Okay, a little bit. Who has read Alexandrescu's Modern C++ Design? That was around 2000 when it came out. Okay, I have to confess, the first time I read that, after page 200, I stopped reading. Who has read some of the standard? Who knows how to access that? Okay, I can point you somehow. And, well, who wrote parts of the C++ standard? only very tiny parts. For me, especially the second row and the second, third, and fourth row are the important parts that I want to convey to you, that you no longer should write U. Use well to how to use the standard containers, especially vector, because that's the most versatile and usually the most efficient one. And to use algorithms instead of writing your own loops. That's important parts that you should take home from this date. And that's my phase of traffic signs of things you should or shouldn't do in C++ 11 and 14. And if you look closely, you might not be able to read all of that. There's a whole things of constructors and destructors that you shouldn't write yourself. You should rely on the compiler-generated parts. You shouldn't use new or delete in your own code. There are factory functions for getting you smart pointers to manage the memory automatically. You should use the Harris algorithm function or numeric to have canned algorithm instead of writing your hand loops. You should use with C++ 11 auto, which is quite a nice thing to do. And also you should write unit tests for your code. Who's using unit tests or writing unit tests for code? Who has never heard of a thing called unit test? Okay? Who has never written a piece of code that tested other code? Never ever. How do you test your code? So you run it and you hope it produces something. Okay, you shouldn't come to my classes. That's our students will fail their term projects or thesis projects if they don't have test automation. That's one of the key features we learned from agile development. I would say that's the most important thing to take home from agile development, writing automated tests. And best before you write the code, because then you know what your code's supposed to do. Okay. We will revisit all these traffic signs over the course of today. And so I said simple, so let's start small. That's the smallest valid C++ program you can write, consisting of about, I'm hard to count, 10 characters or 11. You have to have a new line at the end. And it defines the main function. Compiles, runs perfectly. You can do it even smaller, but smaller is not always simpler. So we see the main function has a defined return value type, and we don't write a return statement. That's one of the specialties of main. Main always returns an int, and if you don't return anything deliberately, it will return the status of the int that says everything is okay. Question?
How do you write a unit test for that?
That's the perfect question. Main is so special you cannot write a unit test for it within the language. Because you're not allowed to call it from within the language. It cannot be called from outside. So main is a big thing that you cannot unit test. That's a very good question, because my recommendation is to have main as simple as possible and not have any logic in main because you cannot test it. Always call out to functions, to regular functions that you can test. Whenever you see a program where main is more than, let's say, 3 lines long, maybe 5, or has any kind of branching statement, that's bad code. because you can attest. But to show you that smaller is not always simpler, you can even make a simpler valid C++ program consisting of 2 characters, an underline and a new line, and it's valid C++ and it compiles and runs. Who knows how to do that? That's to show off. That's not simple code, that's obfuscated.
What do you mean that who knows how to do that? Do you mean how to run it?
But you compile it and run it.
So you just type it and run it?
You can make it do everything that you want. Any idea? If nobody knows the answer, that's good. Yes, one?
You could define a macro or something like that for the compiler.
So we try to define a macro, and that's exactly how it's done. Underscore is a valid identifier in C++ and C, and because it's a valid identifier, you can define a macro that is exactly defining that identifier to be some replacement. And we can define that on the command line of the compiler, like that. So this would be the even smaller program where an underscore is defined to be int main and whatever you write in that main function. Don't do that. It's just to show off. There's a question?
So why is this new line needed at the end? Is this kind of an OR specific element?
The compiler will warn you if you don't end your file with a new line, and all IDEs will insert that automatically for you. That's just to avoid the compiler warning. But otherwise, new lines are insignificant, more or less. Okay, so simple is good, obfuscatingly simple is not good. So you can always overdo it. That's the message of this slide. And we learned you cannot unit test main, that's bad. Now, there's another. If you use Eclipse CDT or develop and say, I want to have a Hello World program, we get that automatically generated. And there are plenty of things there that are really, really bad practice. And I want you to help me figure out what bad practices we find there. Any ideas? What are you not happy with in that piece of code?
The namespace.
So using namespace?
Yes, I would just refer specifically. It's on cout and line.
Bad. So using namespace in global scope of the namespace std can be very bad, especially in header files. It's really, really nuisance because you introduce all names from that namespace into the current scope, and if that's a global scope, the global namespace, it can be bad because you can get name clashes with your own code, for example. And here we only have it for 2 places, cout and element, which are elements of the global of the standard namespace. So you could easily put std : in front of that without adding more characters to the code. There's even a refactoring in Cdevelop that allows you to inline the using namespace std, and it will prefix all the relevant identifiers with the namespace scoping in front. Anything else? There's more. Anybody not understanding completely what this piece of code does? No. Okay, so basic C++ knowledge is there. Yeah?
Well, the return 0 at the end, this 0 is there is a macro for return success or return non-success. So I think they should be used.
In C, there's a macro called exit success that you could use in a return statement. But since I told you just on the slide before, the return statement in main is superfluous and it will return success anyway, so we can just get rid of the return 0. On the other hand, 0 is guaranteed to to tell the environment that the program ended successfully. So first the macro is superfluous, second that's C, and return 0 is superfluous in main. So we can get rid of that line in the code, so one line less. What else? There's more.
Personally, I like command lines. For example, RC, RP in the main. I don't like end line, for example. Just put slash and.
So
I think this is our problem.
You cannot overload main as all other functions, but main comes with two signatures. One is without any parameters, and the other one is with the argument count and an array of character pointers denoting the command line arguments. Since we don't use the command line arguments here, it's okay not to have them. But that's not something I was asking for. There's more things that are bad here. I'm not sure how well you can see the greenish parts on the other restaurant. Okay, there's a block of comments at the beginning. Those comments are the biggest, let's say, time waster in many areas, especially if you put nice little stars to mark the right color, which this doesn't. First thing, this information, the file name, the author, the versioning, today belongs in the version management system, and that should be Git. If you still use things like Subversion or CVS or even more ancient things, use Git. Start tomorrow, or maybe the day after tomorrow. Tomorrow needs your attention.
What about compressed files passing around tarballs?
That's not version management.
I know.
So if your version management consists of burning a CD or DVD of your source code every other week, that's not version management. Version management means every little change where you ran successfully your tests on, you check it. And then have a build server that checks that your tests still work there. So all that stuff doesn't belong in source code anymore. We no longer print out files, I hope so. So we no longer need that information in a hard printed copy. That was true in the 80s when we still had these chain printers that made nice asterisk printouts and also listings, but today no longer. Then there's another comment there. The one that exactly tries to tell us what this code is supposed to do. Anybody who needs comments like that explaining the source code in English or Italian or German to them should no longer run the compiler, because that person is not able to understand the tools he or she is using. Don't write comments explaining the code. Write code that explains what it does. And if you don't know what cout shift means, then you shouldn't run a C++ compiler at all. So no silly comments. There used to be a time where comments has been helpful. I would say assembly language, when you had to write assembly language without a macro facility, their comments might have helped to get to explain what it's done, because not everybody might be knowing all the mnemonics that you use in your assembly code, but no longer. So that's a silly comment. There are two other things here that might not be as obvious. Who knows what ANDL actually means? It does.
That's a flush.
It puts out a line feed and it flushes the stream. If you write a web server using ANDL, for every line feed you create, you write the worst performing web server ever.
That's why it's less Punch the backslash right now.
So the better thing is to actually add a backslash n, which considers the new line character here at the end of the hello world string with the same effect, because especially at the end of the program, the standard output stream will be flushed anyway. So that's it's superfluous and it is very performance. You see many example pieces of code where people use angle. The only useful, let's say, reasonable use for angle to get its flushing performance is when you output something and expect the user to see it before you ask him for input. But that's something that rarely happens, and especially there might even be automatic flushing between if you send it out and send it in, so C out and C in, because they will interlock with the flushing. Whenever you read something from send it in, from C in, C out will be flushed automatically. So that's it. There's very few cases where angle actually is used.
Can I ask a question?
Yes.
Not on this topic, on the one on the comment, on the top comment. I see you there. You said your copyright information, right? Do you suggest removing that too, or
yes,
or not?
If you have a copyright on your code, put that in a license file accompanying your library. Your code will be more than one single file, and putting it in a single place also it gives you the don't repeat yourself thing, especially if you want to change the license or provide multiple licenses. Adding that to every source file can be quite a nuisance.
But how do you protect the code from someone stealing part of it?
You cannot protect it anyway, and implicitly in Swiss law, actually anything that you write has your own copyright if it is something that has a reasonable hurdle for copyright. So this program would not have to be a copyright anyway, because it's nothing creative going in there. So nothing actually to protect.
I have a question with respect to end line and threading. Is it somehow defined?
Can you use the microphone, because I have a hard time and I might not, if it's a longer question, I might not be able to repeat it.
I don't know how end line behaves in the context of threading. I suppose it's undefined, but is this implementation defined? But is this flush buffer, is it somehow per thread, or is there just one for all threads? I guess it's implementation defined, and if you want to make sure that you have a protected section where you have output, then you need end line to put the whole thing out so that you see the output of one thread, not intermixed with other threads' output.
There's a question, what will happen if I use a stream, especially standard output stream with multiple threads? And the good thing is there is no data race, so your program won't crash or have undefined behavior. But what you don't get is any reasonable sequencing of the output if you use the same global cout object from multiple threads. There is work ongoing, and I'm one of the authors, to having a buffering stream wrapper that will buffer per thread, and where you can have, let's say, a single output, collect outputs and then have a single output that is uninterleaved with other outputs. But as of today in the standard, there's no provision of that. I would say it's luck what you get. So just don't do it. And that actually fits with the last thing I want to show you what's bad. Cout is a global variable. Global variables are extremely bad. And even the standard provides one, and it protects cout in case of multi-threaded use. It's not very useful because you, as this person said, you cannot guarantee any sequencing of the output if it's used by multiple threads in parallel. And also, you cannot write unit tests to code that uses cout. So the only place I teach my students where cout or cin are allowed is in the main function, and it's to pass them to other functions as arguments. All other code should not use the global variable cin and cout, and no other global variables as well. That doesn't count constants, because constants are not that bad, but non-constant variables are really, really bad. Unfortunately, the standard only has a very few of them, and C out is the most prominent one everybody uses everywhere, which you shouldn't.
What do you use instead?
You pass an O stream as a parameter to your functions, and then you can test your function with a string stream, as we see in a couple of minutes, and then you can test the code. So let's see if we collected everything. So this doesn't belong there. That comment is ridiculous. That's redundant. Using namespace, as you pointed out, is bad practice. Handle is inefficient and redundant. And the global variable is okayish in main. So hello world is still okay, but not anywhere else. Questions? Okay. So how would a better hello world be? Well, the first thing is it should be unit testable. The code that is unit testable must not use global variables, as I told you. Without the using namespace, without the stream, and without the handle. And to show you that, I introduce my little unit testing framework. You're free to use others. This one is built into Cvelop, so you get it for free, and the infrastructure provides interesting part. So the Cvelop also provides test-driven development support and refactoring, so you can actually write a test case and let the IDE generate the code that you wanted to test from it. Not all the logic, but at least the API, the interfaces, the class types that you use. And why did I create my own unit testing frameworks? There are plenty of those around in C++. And there are two reasons. One is many of them use macros very freely for a lot of things. And I try to minimize the use of macros in Qt. And we are working on the standardization committee to provide infrastructure that we can get rid of all macros for unit testing. We're not there yet. There's a proposal for the only area where Qt still needs macros is to actually get the source code positions where a test might fail and the names of the test functions. Both of those will be able to get rid of in the future by providing standard facilities that don't rely on the preprocessor of C++. The other reason is that a lot of unit testing frameworks, including the famous Google test, which is quite ancient from its architecture and construction and C++ usage, rely on macros that create code that instantiate global variables, and that instantiation of global variables has a side effect to register the test cases. And in C++, the instantiation of global class objects across compilation units, the sequence is not defined. It's whatever you get, you get. And if you have dependencies, especially if you end up to have circular dependencies, you might end up using a global variable from another compilation unit, especially another DLL or shared library, that might not have been created or completely fully instantiated when you use it. And that leads to nasty bugs at program start time, especially in your test cases. And I've been hit by those in the 90s when we created our unit testing framework with those kind of fancy self-registration macros, and we needed to get rid of that to have our code that used many shared libraries, also the test cases used shared libraries, would no longer work with this self-registration. So self-registration of unit testing framework is considered harmful in my opinion. That's the reason of that. Of those of you who have no idea what I was talking about right now, don't mind, just don't do it. Now, this is a piece of code. Yeah, you might see on this projector, there's the dark pinkish part. That's code that is automatically generated for you by the IDE. And what you would need to write is actually write a test case. Test say hello, says hello world. And the trick is to replace the output stream cout by a output stream ostream parameter to the function you want to test, and use a so-called string stream object and pass that string stream as an argument. And with the string stream, a string stream will collect all the stuff that you would write to, let's say, cout instead, and will tell you what has been written out. And we assert that our hello world, say hello function actually tells us hello world and a new line. That's the expectation here. So the typical test case is set up something, call what you want to test, and then assert that the output or result is what you expected. It's called AAA. Arrange, act, assert. That's always what you would do in test cases. What you also would do, you would usually test a single thing. Not one test per function, but one test per feature of a function. Why? Well, if you have multiple asserts in a test case, you might not be able to tell quickly which one failed and why. If you have a single assert and a single fact that you test, a failing test case will tell you immediately what went wrong. Maybe because of maintenance change, maybe because of a bug removal that introduced another bug. That is something you want to figure out. If you have bugs in your system, the first thing you should do is write a unit test that exemplifies the bug and then fix the bug. If you have a failing unit test case, then it's easy to never introduce that bug again, because it will actually check for you that you won't get a regression on that bug. Now, to get that working, we have to do some scaffolding. So the typical thing is we separate our library part in this CDT or develop. That would be a separate library project with a header file declaring our function. And we see another thing. We no longer use IOStream as a header. IOStream is dangerous. It should only be used in main, because it will introduce you the global variables cin and cout and cerr. And I told you, you must not use those in a code beyond main. So what you would use in a header file is a special header in the standard library that only has forward declaration of the stream object and some other things. And it's called iosfwd, so pronounced ios forward. So whenever you have an API that takes a stream, use ios forward in the header file and pass a stream as a reference. Anybody not familiar with that reference syntax? Okay. Why would you need a reference there? We want to have a side effect. That function doesn't have a return value. Void says I don't return anything. So the only means that it has something is providing a side effect. And we cannot pass a stream as a variable that we copy and return a copy. That's impossible with streams, because stream objects are made for I/O and side effects. And side effects only come through reference parameters. It also tells us a reference parameter, that's a potential danger point. Whenever you pass something by reference, if you call that function, the call might look innocent, but because of its side effect on the calling environment, it might have heavy side effects. On the other hand, people use references as parameter types because it's efficient. You don't have to copy things around. If you have let's say, a 1,000,000 element array, you might not want to pass this as a copy, but as a reference, so you can have the side effect, or as a const reference if you don't want side effects on that large data structure. But most of the time, passing by reference is potentially dangerous to your code, so be reluctant about passing by reference, unless you can no longer you cannot write the code about that.
Now in your corresponding CPP file, we implement that set function. We include the header file declaring that function to recognize if we have any inconsistencies there. And because now we want to actually use the O stream and this shift operator, we have to include O stream. We don't include IO stream because that would give us the global variables, and we might unintentionally use cout instead of out here and be hosted by using that. So we only include IO stream where we actually have the main function, where we use standard cout, but everywhere else we use O stream or the other header I stream, but never IO stream, because IO stream is not the sum of I stream and O stream. That's the question in the back.
Short question. Why are you including iOS forward in the declaration, so in the library part, and only O stream in the implementation?
There is no OS forward, so I include iOS forward to be able to use the name standard O stream. But it would not tell the compiler what features this class O stream all has.
And you cannot include O stream in the declaration?
I don't include it here because I could have included O stream here, but that would make my header more complicated than it needs to be, or more to compile than it needs to be. So this is a kind of frugality to make fewer dependencies in your header, the fewest one that you can have, and it also can increase, can decrease compile times if you don't include too much in your header files for other people's using your. Let's consider you have plenty more functions in your header file, and some other part of the code only uses those functions that won't pass in a stream, wouldn't call that function, but all the others. Then that function, compilation unit would not need to use any kind of the stream headers completely if it's not calling out to that. So you would save on compilation time on that part of the library.
Just to rephrase what you're saying, including the forward, just include the lines like that one with say hello to with the semicolon at the end. Just to find the name of it, the signature, the thing, but it doesn't give the actual implementation, which is given afterwards. So you include the forward, gives you the name, and you can use the symbols. And then when you actually need to use the function, you include the headers. Am I right?
Perfect explanation, Mauro. Thank you very much. And now where did I stop? Well, I think almost everything has been said. I'd just like to show you how things would look like in the IDE. So don't be confused by these strange underlines. I just set up this workspace last night and I might have some, oh yeah, I have some compilation problem here. Sorry, should have tested before. Wrong compiler. Now things get better. Okay, now you recognize this is the code that we are actually using, the O string stream. And let's try if we can compile that. Oh, come on.
I should have cleaned everything. So we see the so-called green bar, which says everything is okay. Now actually, if you have spotted before, I added here a comma. And let's see if I compile it without the comma. And my IDE is still working in the background. That's why you get all these little red wiggly lines, which shouldn't be the case. I see, okay, there's a difference here. I expected hello world without a comma, and the actual code provides the hello comma world. And that's a typical scenario, a little typo, a little discrepancy in what you expect to what you got. So either it's the expectation wrong or the code is wrong. Let's pretend the expectation now is correct. So how do we fix that? We go to the test case. We control click here, get to the code, control click again, and we see, okay, there's the bug to be actually fixed. Get rid of the comma, save everything, rerun the test cases by recompilation, and everything is green again. You always want to have that kind of green bar in your code. There's a question in the very back.
Here in the scientific world, we often have floating point results, and they are sometimes a little bit unpredictable, depending on threat orders and all kind of strange stuff. So how does this unit testing framework, does it support it in any way, or what? Have you seen people that use these unit tests with floating point results, like huge matrices or something like that?
So the question is, what do we do with floating point numbers? First thing, you cannot easily assert equality of floating point numbers because they might differ in very insignificant bits. That's one thing that the framework takes care about. Let's say if I say assert equal 42x times y, let's see if that's correct in any sense. Something's broken with my indexer. Okay, yeah. Now if we control click on that macro, oh no, we should not have done that. If I hover on the macro, I see the macro expansion. And actually what happens here, there's a specific version in the framework that deals with floating point equality. And it will use, there are two options. First thing is you can use assert equal delta, where you say 42x times y, and add whatever accuracy you expect to get. So is that half of your answer, half of the answer of your question? And the other thing is, if you look, dig deeply into the code that actually happens here, it will, if you compare to floating point numbers, it will automatically compute that delta from the type of the floating point value plus the numeric limits of that floating point value and down to the last decimal digit. So it will actually chop off the last decimal digit of the accurate representation of the size, depending on the size of what you expect the value. So that would be, let's say with a double, you have, let's say, roughly 15 decimal digits accuracy, and we'll chop off the last decimal digit of the accuracy when comparing these two numbers. Is that sufficient for your needs?
Well, yes. So far, yes.
What wouldn't work yet is if you have, let's say, a large vector of floating point values. Comparing these two vectors of those floating point values will still use equal of the vector class, and that will compare floating points by equal, not with this delta mechanism. If you want that, you would have to write your own comparison function.
I guess it would not be enough if you have distributed data or something like that. Then it would be.
If you have data where accuracy is not significant, you still can compare very inaccurate. And if you have, let's say, significant differences, then you should rethink your algorithms. You might just get the wrong results anyway. And I know there is things like weather simulation where you get different results with tiny changes and you cannot actually compare expected results with what you get. But again, there's something you might be able to do about that. I'm not an expert in numerical computations, but I know there are things that, such as error propagation and so on, and that's beyond the scope what I can teach you now. You might have wondered what these little green C's are there. That's something just new. That's I just installed a plugin of my student that I'm working on. It actually tells me something. You should const qualify that identifier. Who has used const in his or her C++ code so far? Okay. Who is always using const as much as possible? Cool. Those who don't, follow the others, because const qualification actually makes your code safer, especially against changes and evolution, because you might inadvertently reuse a variable or use it for a different purpose. And there are only a few variables that actually need to be modifiable. Usually those where you have a side effect, or those that you use as a loop counter or accumulator in a loop. And you better use canned algorithms for that without introducing your own variables. So we can even quick fix that. Pressing Control 1 adds the const qualification here, and we will be safe, and the code should still run. So it still works, okay. More questions. So something I didn't show you, that is code that is generated for you, and it will generate automatically also the thing where that says Q as pushback that actually registered the test functions with the framework so that they are called later on in the when the unit tests are run. And this registration is done at runtime, not at compile time, and not at program startup time with globals. And it's automatically provided to you by the IDE, so it will actually auto-generate that code. And if you, for example, forget to register a test case, it will mark it here with the yellow thing, and I can just add the test to the suite, and it will add the code again to the run all tests function.
So what is the rule? The test functions should start with the test string?
No, it will look into the function body if there's one of the assert macros or deliberately the underneath lying function calls, then it will mark it as a test case to be added to that function.
It's more advanced than what I was.
No,
I would have done, basically.
An abstract syntax tree behind that we use for all these kind of tests, especially the const thing. You have to use the syntax tree to figure out if something is used as a variable or just initialized. And we have seen something C++ 11-ish here. Those who haven't recognized it, these curly braces are for initialization. That's C++ 11 syntax. And if you write it the classic way, let's say with equal, I didn't activate that. Let's see. Come on, no, it wouldn't. It wouldn't do that. Let's say if I forget that, it shouldn't mark. I get a little star here, and I can add the initialization and add something there. Okay, it will provide you with the curly braces if you don't have them there. So sorry, I can't hear.
What is the advantage of this kind of initialization over the standard or the old way?
Well, the old way you might be able, you might forget it to initialize. It's easier to provide default initialization with just the curly braces, which you couldn't do that easily with other means. So you could have written something like, or let's say, with equal, and you want to have a default value, you have to spell that out. Let's say, that would be a default construct double, or you would write 0. In some cases, you could write that already, especially if you have a plain arrays and structs for initialization. And the C++ 11 just got rid of the equal sign. And as we will learn soon, there's also something where you can automatically deduce the type of the variable with auto. And to distinguish those cases with auto from the cases where you have specified a type, it's where you use the curly braces versus auto, where you always have to use the equal sign. Another question?
Yeah. Sorry for just posing this question already, but what would happen in this case actually if I replace these two doubles with auto? Would it be able to deduce that this is a floating point number because we have an assert with 42.0?
No, it wouldn't look that far. So the point is, if we would write auto here and say equal 6, then it will take the type of the value on the right-hand side, and that is an integer literal, so the type will be int. And the IDE is, in many cases, smart enough to show you what it deduced from auto, which is constant in this case, the type of the variable x. So if we want to have floating point, we need to write the floating point number on the right-hand side. So like we have to say 6 dot, and then we get back the double. So we have to specify the floating point literal. And that's one of the advantages and curses of C++, especially numeric types. They convert freely, and the compiler might not warn you about any kind of cutting off a floating point value to an int or promoting an integral value to a floating point value. More questions? Let's get back to my slides then. Okay, that's I all said to you. Maybe unit testing deliberately. If you have I/O, use string streams to test the I/O. For numeric type, you might just use strings because for let's say output, you might just use strings in some cases, especially if you have there's something new in C++11. It's toString function that actually is for converting numbers to strings, and that's quite convenient. You don't have to use string stream to convert a numeric value to a string representation, or sprintf. Who's using printf as printf still? Don't. What we do in the unit tests, we use a pattern called parameterized from above. So instead of relying on global variables, we pass in all dependencies as parameters, and that's important to actually make testable code. And don't use global variables in our stream. I said that already. And now to the motivation for auto. I already told you there's something called auto for type deduction in C++11. And if you ever write a loop yourself that uses iterators from a standard container like standard vector, spelling out those loop variables is quite tedious. You might have to type things like standard vector, standard string, const reverse iterator it equals v.rbegin, if that vector happens to be a const vector. And that's tedious, and nobody's doing that. People using vector write for int I equals 0, I less than vector size, plus I instead. But it might be harder to get the reverse iteration correctly on the first time. And especially if you want to save a value in generic code, you might need, if you have an iterator IT of any kind of iterator type, which might just be that above here, you can, to actually specify a variable that takes the value the iterator refers to correctly, imposes to using iterator trace of that iterator type, which could be that long. And there, the value type, and you, in generic code, you might need to add type name in several places to get that right, to define the variable v, to take the value that's stored at the place where the iterator points to. Anybody written code like that so far? Okay. Did you like it? And that's what gets better in C++11. And sometimes you have library function, like the function binders, boost bind, or C++11, you now also have bind, or bind first, bind second. Anybody used bind first, bind second so far? Anybody has used the function binder, boost bind? Okay, we have something to teach you. There's someone who might have heard about that. They deliberately have a return type that you cannot specify, but now we can save that in a variable. And there are other, if you have factory functions like make shared or make unique for smart pointers, you don't want to spell out the smart pointer type yourself. You get it for free with auto as type deduction. So the type deduction with auto works like template argument type deduction. And if it's deduced from an initializer, so we use equals or assignment equal. And for local variables, we can use auto and then equal whatever expression we want to initialize it with. Who knows what's bad in these three lines, auto var, auto a, auto rest? Now that's a trick question, but I want to see if you paid attention. What is missing or wrong in these lines? Auto var equals 42, auto a equals func, auto res equals add. Can you use a mic so
There is not the const, for example, maybe from the first declaration.
Exactly, const is missing. I told you, use const whenever possible, and typically a variable that is initialized, especially by a function call, you might not want to change that variable afterwards. So the chances are high that const is missing these 3 lines. There's another question in the back.
I think in C++11 you can attach a hint to the compiler that something is aligned as, and does auto somehow transport this feature to these variables? I mean, it's very important for me at least that if something is aligned that the compiler knows about it.
Oh, in C++11 we have standardized a feature called align as, which allows you to, let's say, map data to specific addresses or addresses with the specific rounding error, and auto has nothing to do with that. And if you would use, I've never used align as in, let's say, regular code. That belongs in specific libraries that deals with memory management and things like that. You shouldn't use things like align as in user code. If you care about those, that's not something you should care about. Maybe Mauro can tell us something about that.
Well, if you do auto var equal 42, you get an integer, and that will be aligned as an integer.
Yes.
If you need to get something, an integer aligned has a double, then you probably want to say it. The compiler cannot do it for you. If you need that, you can. You just have to.
No, the alignment is not transitive.
And this is autovar creates a new variable copying the 42 into there. If it is autoref, that's probably innovating the alignment, but it's a reference to the value.
Okay, but I think alignment is beyond the scope of what we're discussing now. So 90% of the course, you just were right not to listen. Okay, there's another use of auto, and that's even more prominent in C++14. In C++11, you can use auto as a return type of a function to specify the real return type after you have seen the parameters with an arrow. And that syntax gets introduced because of lambdas, which we see in a moment, maybe after the break. And it's valuable in generic code, where you have a template code, and you can make the return type depending on an expression that you might use as a return statement. That's C++11. In C++14, you don't have to specify that return type. The compiler will use it automatically for you anyway, regardless of the complexity of the function. But in C++11, you still have to specify a return type when you use auto as a function return type. So just take a compiler that's C++14 compatible if you can, and you don't have to specify function return types anymore. But sometimes you want, especially when you don't want the function to be inline. That's C++14 version. So in C++14, we don't have to specify the return time. It can be automatically deduced, depending. The function must be inline. The function body must be visible. So you can forward declare such a function, but you cannot actually use it well unless you have the compiler has seen the function body. And there's another version that a thing called Deckel type auto. And Deckel type auto, let's say in layman's term, it keeps the referenciness, which isn't a word and a valid term, of the return value. So X here might be a reference in that specific piece of code, and then Deckel type auto will return the reference that was passed into that function. It's called ID because this is the C++ version of the identity function in generic code. I hope so. But that's usually not. Auto is used often. Deckel type auto is more expert knowledge required. So now what can we do with auto, even in C++11? We can use it to keep iterators around that we got returned from algorithm calls. We could use it to have, let's say, complicated value types like a standard map, which uses a standard pair of key and value, and spelling that out is quite tedious, and auto is a lifesaver there, assuming the map is not empty. We can use auto reference to keep references around. And the bad thing is, until maybe C++17, I believe, is if you have auto and use these curly braces, then the type deduced is not an int in that case, which you might expect, but it's an initializer list of int. Why is that? Initializer list is a new standard type introduced with C++11 that takes a list of values in curly braces, and this is a type that you use, let's say, to define a constructor of vector to get it initialized with a list of values. And if you just use these curly braces with a single value, again, it will also be deduced as an initializer list. But that will change in C++17, I believe.
There is some controversy, I guess, on this one, right?
I believe Microsoft wants it to change, and I'm not sure if it got voted in yet or not.
So, can I somehow also define the width of the variable? So, for example, if I don't want to have an int which is 32 bits long, but instead of a 64-bit int or a size t which is unsigned, because in some cases I might have unintended side effects if I use auto for initialization and then I multiply these values, and then I might get a negative value as a return because it got deducted as an int.
If you work with integral values, there's no reason to use auto everywhere. It's useful if you have things like find algorithm, or just spelling out the type is very tedious. But using auto instead of int, or a size t, or unsigned, that's something where you might consider spelling out the type instead. It's very useful in generic code, when you might not have easy means to spell out the type at all. There auto is a real lifesaver. But in cases where you write equal 42, there's no problem to use just 3 letters and spell out int. And if you want to know let's say, the bit size of the integral value, you can still use C standard int types like int32 or unsigned, uint32 or something like that. My rule is always use equal. When you have type reduction with auto, then you're on the safe side, not getting an interesting unintended side effect of the initializer list type. Useful parts for auto, again, some examples. Defining iterator variables that you get from either the iterator factories of a container like vector, or from an algorithm where you use where you get returned an iterator value. Very convenient if you spell out your own iterator for loops, and that's a new feature in C++11. You have this range-based for loop. Those of you who have programmed in Java or C# will know that you write a container on the right-hand side of the colon, on the left-hand side the variable that is bound for each element in the container for each loop iteration. And you can use references if the container is non-const. You can use auto, you just get a copy, or auto-const, you get a copy that you will not be able to change, which is quite useful because any change to the variable, if it's not a reference, will not change the container. So these are actually the two versions of the loop that I recommend. Unless you have very large elements, then auto-constref might be useful in that case to avoid the extra couple. And the good thing is it won't have a one-off error there. It will never loop if the container is empty, and it will loop exactly for each element in the container. But there are better uses at all. And when do we have to break?
No, we can break now, I think. And yeah, the break was at 10:15, so perfectly.
So
how long
let's see what's on my next slide. I think that's the curly braces we've already seen, and I already told you. Let's use this. This kind of initialization works even in C, and that used to work in all C++. And this kind of initialization used to work in C++ so far. The interesting thing, who knows what F and T is? In that case, if you declare something like that. Where is the smart guys? Go ahead, give you the microphone.
Function declaration. It can be confused with a function declaration, right?
So F and T are neither variable declarations but function declarations. The good thing is that's just perfect C++ syntax, so you won't get a compile error. But the nasty thing is if you then use that, you might get very interesting effects. It might even compile correctly by passing that as a function pointer. You might get a linker error because F is missing. In C++ 11 we can use the curly braces to either initialize with value, default initialize, or give a vector with a list of elements, which is quite convenient to get some starting values if you have a few. Especially in test cases, that's quite nice. The bad and ugly thing that we still get, vector used to have overload constructors. For example, one that takes the number of elements and the initial value. And if you have a vector of int to actually call that constructor with the number of elements and the initial value, you have to use the parentheses and not the curly braces, because the initializer list constructor would take precedence over this one, and it would initialize v2 with two values, 10 and 0, whereas v10 is actually 10 times 0 in the vector. So that's one of the ugly warts of backward compatibility that we have to live with in C++. The good thing, as long as you use curly braces, you never end up where the mouse cursor is there in the situation where you inadvertently declare a function instead of defining a local variable. And I think that's a perfect timing for a break. Just remember round parentheses for definition, if you define a constructor, curly for construction, and that's easy to remember. If you construct a value, use curly braces now. And that's time for break. Is that okay?